Okay, in this section, section 6.3, so we're going to solve the same problems that we did in the first two sections, but with a different technique. And this way is actually easier for the most part to do, doing them this way. So what we're doing first is talking about something called a matrix. So, in the last section, maybe we solved a problem that looked like this. We had like 2x plus y plus z is equal to 3. 3x plus y minus z is equal to 2. X minus y minus z equal to 15. Something like this. Another way of writing this is something called a matrix. So a matrix is we have a parenthesis, and whatever variables we have to have a column for that. So we have to have a column for x, y, and z. We have to kind of take care of these equal signs. The way we usually do that is just with this like vertical bar. And on the right-hand side is going to go to the numbers. And what we put here are the numbers in front of the variables. So like we have a 2 in front of the x, a 1, and a 3. So all I'm doing is writing 2, and then 1, 1, and then 3. The next row, we would have 3, 1, minus 1, and then 2. And then the last row, we have 1, minus 1, minus 1, 15. And so there's, like we said last time in class when we were solving this problem, there wasn't one way to do it, and there wasn't really a method. And you kind of have to do some careful thinking and then just work your way down to the answer. When we use a matrix, that's not the case anymore. So there is actually like a pattern that we can solve that works every single time. It's basically this little, these two things right here. This is how we can go back and forth. So if we're given a matrix like this, we could turn it into equations like this. If we're given equations like this, then we could turn it into a matrix like this. So we can do this both ways. So how do we do this? So the goal is, so we're only going to do two situations, either if we have 3 variables or if we have 2 variables. So let's just talk about 2 variables. The idea is the same in both, but there's an extra added step if we have 3 variables. So the goal here, so say if we have some matrix, let's say we have, how do I want to do this? Maybe this is going to be A1, A2, B1, B2, C1, C2. So here's our matrix. So remember, this is the same thing as A1x plus A2y is equal to C1. And then B1 plus B2y is equal to C2. So if we were going to turn this matrix into equations, it would look like this. So what do we do here? So we want to solve for x and we want to solve for y, just like we did in last section. In last section, we did either substitution or we did elimination. So what we're going to do now, our whole goal is to turn this matrix into something like this. We want a 1 here, a 0 here, a 0 here, and a 1 here. And then there's going to be just a number over here, and then another number over here. So this is our whole goal, is to turn it into this. And what we're allowed to do is we can take, so if we say the word row, maybe we should put this off to the side. A row represents this, and then a column represents this. So a row goes sideways and a column goes up and down. So what we're allowed to do is we're allowed to take an entire row and multiply it by a number. And we're also allowed to add and subtract rows together. We usually don't mess with just columns. We only talk about rows. So we're allowed to multiply an entire row by a number. We could also take this row and subtract it from this row. And so our whole goal is to then, like how we said below, we wanted to get to have the left-hand side look like this. And the right-hand side look like this. So the way we do that is, the first thing we're going to do is, so using these letters above, A1, A2, B1, and B2, we want to make A1 equal 1. So somehow we want to turn that into, let's see, how do we do this? How should we say that? Let's turn A1 into 1. This will be like the first step. The second step will be turn B1 into 0. And then the next step, turn B2 into 1. And then Next step after that would be to turn A2 into a 0. So notice that if we did that, we would have the 1, 0, 0, 1, but we want to do it in this exact order. And the ways we can turn A1 into 1, there's many ways we're allowed to do this. So it just depends on the certain problem. But these are the 4 main steps. So basically the idea is we start up here, we want to turn this into a 1, and then everything beneath of it is 0. Then we move down this diagonal, we want to turn this into a 1, and then everything above it 0. Okay, so let's do it with a couple of problems. Let's do number 15. So we want to solve 4x plus 2y is equal to 11. And 3x minus y is equal to 2. Okay. 3x minus y is equal to 2. All right, so we want to solve this by using a matrix. So put this into a matrix. We're going to have 4, 2, and 11. And 3 minus 1 and 2. So we look above, we said turn A1 into 1. A1 was the thing on the top left. So turn this into 1. So we have several ways to do it. Well, we could just take, one thing we could do is we could take this entire row and divide it by 4, because then we'd have 4 divided by 4 there, which is 1. So that's one option. Or how about if what we could do is we could take this row and subtract this row from it, because then we would have 4 minus 3, which is 1. So let's do that second thing. So the way we say that is our old row, so this is going to be our new row 1. It's going to be the old row 1 minus the row 2. And then we're just going to rewrite row 2. So for this new spot right here, we're going to take our old row 1 and subtract our old row 2 from it. Okay, so what we have there is 4 minus 3, which is 1. 2 minus a minus 1, which is 3. And 11 minus 2, which is 9. And then we just rewrite the old row 2. 3 minus 1, 2. Okay, so that was the first step. So what we did there is now we have a 1 in the top left spot. And then you look at step number 2 is turn B1 into 0. B1 was the thing right beneath of 1. So how do we turn that into 0? Well, the easiest way, let's just rewrite. Okay, now we're going to rewrite our old row 1. So now our old row 1 is this one. So these always represent the one previous. So let's just rewrite that, because we don't want to change this. We want to keep this to be a 1. So once that's a 1, we want to now just only work on making the thing beneath of it a 0. So let's just write that. We have 1, 3, and 9. Now to make this a 0, what we could do is actually just subtract 3 of this row from it, because we have 3 minus 3 then, which is 0. So what we're going to do is we're going to take our old row 2 and subtract 3 row 1 from it. So we'd have 3 minus 1 times 3, which is 0. Minus 1 minus 3 times that. So minus 1 minus 9, which is minus 10. This minus 3 of that. So 2 minus 27, which is minus 25. Okay. Yeah. Okay, so we're all good there. What was up there? Row 1 minus row, that was a 3. All right. 1 minus that 3, that minus that. Yeah. All right, so now we're at this step. And then if you look at the last thing we said, number 3 is turn B2 into 1. So the only way to turn, so B2 is this piece. To turn that into a 1, let's just divide that whole row by a minus 10. So let's not do anything to row 1. So now let's do row 2 divided by minus 10. So we can have 1, 3, 9, 0, 1, and then 25 over 10, which is 5 over 2. Okay, we're almost done. So now what we want is, if you go to the next step, turn A2 into 0. A2 is this piece right here. So the easiest way to turn that into 0, let's just take that row 1, and subtract 3 of row 2. Because then we'd have 3 minus 1 times 3, which is 0. And then we're going to just rewrite row 2. So we'd have 1 minus 3 times 0, which is just 1. 3 minus 3 times 1, which is 0. And then over here, let's just write it out. We'll have 9 minus 3 times 5 over 2. And just rewriting this row, we have 0, 1, 5 over 2. So notice that we're good now. The left-hand side is equal to 1, 0, 0. 1 is what we wanted. So let's just simplify this piece up here, the 9. Let's also should start this a little bit smaller. Okay, so that 9 minus 3 times 5 over 2. So what does that equal to? So that's going to be 9 minus 15 over 2, which is going to be 18 over 2 minus 15 over 2, which is just equal to 3 over 2. So what this ends up becoming is 1, 0, 0, 1, 3 over 2, 5 over 2. Okay, so why does this mean that we're done now? We said before that all we wanted is to have 1, 0, 0, 1 over here, and then just 2 numbers over here. But remember, so say if we want to turn this back into equations, well, here's our x column, here's our y column, here's our equal sign. So what this means is we have 1x plus 0y is equal to 3 over 2. And we have, then the next row, 0x plus 1y is equal to 5 over 2. But 0y is 0, so that top thing just tells us that we have x is equal to 3 over 2. And the bottom, so this is going to be 0, so we just have y is equal to 5 over 2. Okay, and so then here's our answers for this one. So once you have, the left-hand side looks like this, 1, 0, 0, 1, this is going to be your x, and that's going to be your y. Okay, the next one about 22. So let's do the same thing with this, x minus 4y is equal to 9. And then 2x plus 5y.
Excuse me, sir?
Okay. 2x, where are we at? Is equal to 5. Okay, so here's this problem. Split it into a matrix. All right, so we said before, the first step is always to make the top left thing a 1. So that's actually already done for us in this problem. So the next step was to make everything beneath of it a 0, so which is just that 2. So the easy way to do that, let's just rewrite row 1, and then we're going to take row 2 and subtract 2 of row 1 from it. So row 1's the same. The next one will have 2 minus 2 times 1, which is 0. 5 minus 2 times minus 4, so that's going to be 5 plus 8. Which is 13. Okay, now 5 minus 18, which is minus 13. All right, so now we have everything beneath that as 0. So now the next thing was we move from here down the diagonal, and now we turn this into a 1. The easiest way to do that, let's just divide that whole row by 13. So let's rewrite row 1 to be the same, and we'll do row 2 divided by 13. So this is going to be 1 minus 4, 9, 0, 1, minus 1. Now after do that, everything we start here go up, all these have to be 0. So we have to turn that minus 4 into a 0. So what we could do to do that is let's take row 1 and add 4 of row 2 to it, because then we'd have minus 4 plus 4, which is 0. And then rewrite row 2 to be the same thing. So we'd have 1 plus 4 times 0, which is 1. Minus 4 plus 4 times 1 is 0. This is still down there. And then this, so 9 plus 4 of that, which is 5. Okay, let's erase all these little circles. So remember we said when we have 1, 0, 0, 1, this is going to be our x, and that's going to be our y. So what we have is x is equal to 5, and y is equal to minus 1. Okay, now let's talk about if we have 3 variables. So in this problem now we say we have A1, A2, 3. Something like this. So let's actually move this over a little bit. So this represents, remember, this would mean we have A1x plus A2y plus A3z is equal to D1. We'd have A2x, or sorry, B2, or B1. Plus B3z is equal to D2, and then C1x, C2y, C3z is equal to D3. So we'd have that system of equations. So in order to solve this, we want to do that same thing. Because last time, just we're doing one extra step. We want to start at the diagonal. We always want to turn this 1. Everything beneath of it is 0. Then we're going to move down, make this a 1. Then everything beneath of it is 0. And also everything above it is 0. And then we move down the diagonal, make this a 1. And then everything above it is 0. Okay, so let's write that step down. So the first thing we want to do is turn A1 into 1. And then after that, turn B1 and C1 into 0. Okay, next we're going to turn B2 into 1. And then right after that, the next step is going to be turn A2 and C2 into 0. Okay, our fifth step is going to be turn C3 into 1. And then the last step would be to turn A3 and B3 into 0. Okay, so 6 steps, always in this order. And so let's do some examples with this. How about we can start with 27. Okay, so 27 is we want to solve x plus 2y minus 3z is equal to 9. Then we have 2x minus y plus 2z is equal to minus 8. And then we have 3x minus y minus 4z is equal to 3. Okay, so the first step is let's turn this into a matrix. So we're going to have 1, 2, minus 3, and then 9. And then 2, minus 1, 2, minus 8, 3, minus 1, minus 4, 3. Let's make sure we copied everything down correctly. So 1, 2, minus 3, 9. 2, minus 1, 2, minus 8. Okay, so all looks good. So like we said, here's the steps. Turn A1 into 1. A1 is the thing on the top left. That just happens to already be done for us. So the step after that is now turn everything beneath of it into a 0. So what we can do to do that is, well, we're going to leave row 1 the same. We already have a 1 right there. We don't want to change that. And then we're going to take row 2, and we can just subtract 2 of this from it. So we could take row 2 minus 2 row 1. So there's a 3 here. What we could do is to subtract 3 of this from it. So we could take row 3 minus 3 row 1. So what do we have? Row 1's the same. 1, 2, minus 3, 9. Now row 2 minus 2 row 1. So 2 minus 2 times 1 is 0. Minus 1 minus, so 2 times 2. So minus 1 minus 4 is minus 5. 2 minus 2 times that. So 2, let's see, minus a negative, so 2 plus 6, which is 8. And then that minus, so see, we got minus 8 minus 18 at 26. Let me just get a calculator, make sure. Because then if you make a mistake here, everything's messed up from this point on. So we have minus 26. Okay, so that row's done. So now let's erase all these circles over here. We have now row 3 minus 3 row 1. So 3 minus 3 of that, which is 0. Minus 1 minus 3 of this, so minus 1 minus 6 is minus 7. Minus 4 minus 3 of that, so minus 4 plus 9, which is 5. And 3 minus 3 of that, so 3 minus 27, which is minus 24. Wait a minute. Hopefully I didn't make a mistake because I don't see a way of not getting fractions at this point, which is kind of annoying to get fractions when you're doing these problems. Let's make sure, I just want to go through everything to make sure there's no mistakes made. Okay, that looks fine. So what do we just do here? Row 1, row 2 minus 2, row 1. So that minus that 0. This is also a good habit. You know, every time you do a step, you should check to make sure it's right. Because if we make a mistake here and we did like 20 more steps, then we just wasted like 30 minutes. Okay, row 2 minus 2, row 1. Oh, we did make a mistake. No, sorry, we didn't. No, we're okay. So we'll go there. Let's see, we have 0, minus 7. Okay, so like we said, now we made everything beneath this as 0, so that's good. What we needed to do now is we have to move down this diagonal and then turn this into a 1. And the only way I really see doing that is just dividing that whole entire row by a minus 5. And why that's annoying is because now we're going to get fractions. So the whole goal is to try to do these things. If we're going to get a fraction here and get a fraction of the second circle. The whole goal is to always avoid fractions because fractions just make things harder to work with. But I don't think we're going to be able to avoid it in this such case. So let's just rewrite row 1. We're going to have row 2 divided by 5, or minus 5. And then just rewrite row 3. So hopefully things will work out. So we'll have 1, 2, minus 3, and then 9. Then we'll have 0, 1, minus 8 over 5, and then 26 over 5. And then 0, minus 7, 5, minus 24. So now we have a 1 here. Now the next step was to make this a 0 and this a 0. All right, so let's do that. So what we can do then is let's take row 1, subtract 2 row 2 from it, because then this would be 2 minus 2, which is 0. And then row 2 stays the same. And then for row 3, let's add 7 row 2 to it, because then we have minus 7 plus 7. All right. We're probably not gonna have enough room. Let's move this down just down to here. Okay, row 1 minus 2, row 2. So we're gonna have 1 minus 0, that's just gonna be 1. Then this turns into 0. All right, so this is kind of where it gets annoying. So we're gonna have row 1, so then this is gonna be minus 3, minus 2 row 2. So minus 2 of this. So we're gonna have plus 16 over 5. And then this minus 2 of that, so 9 minus 52 over 5. Okay. Rewriting row 2 to be the same. 0, 1, minus 8 over 5, 26 over 5, 0, minus 7. Oh, sorry. No, we're changing this row. So this row we're adding 7 of the second row. So 0 plus 7 of that, that's 0. Minus 7 plus 7 of that, that's going to be 0. And then what we have is 5 plus 7 of that. So 5 minus 8 times 7 is 56. So we're going to have minus 56 over 5. And then over here, we'll have minus 24. Oh, sorry, no. Yeah, that's fine. Because we're doing, so row 3 plus 7 row 2. So we're doing 5 plus 7 of this. So that's a negative number. So it'll be 5 minus 56 over 5. And then what do we have over here? We have this plus 7 of that. So minus 24 plus, what's 26 times 7? 26 times 7, 182. We'll have plus 182 over 5. Okay. So let's just look at this bottom row. Well, what does this bottom row mean? Well, this means we have 0x, 0y, and then whatever 5 minus 56 over 5, so that times z is equal to minus 24 plus 182 over 5. Where's my I need a calculator to do this real quick. Where did I put that? 1 second. So to solve for z here, let's just do, so if we did 5 minus, so what does that equal? 5 minus 56 over 5. Okay, so the left-hand side is minus 6.2. And then over here we have minus 24 plus 182 over 5, which is 120, 12.4. Okay, so now that means z is equal to 12.4 divided by minus 6.2, which is equal to minus 2. So we get z is equal to minus 2. So there's one of our answers. So now what we can do is now let's look at our second row. So what does this second row mean? Well, this means that we have 1y minus 8 over 5z is equal to 26 over 5. So what we can do, so basically what we're doing now actually is we're stopping, we had these steps up here. We're basically stopping at turn C3 into 1. We kind of like are stopping at this step. We don't need to necessarily need to make everything above that 1 a 0. So really what we can do here is, so basically we're just kind of like taking a little shortcut. Once we find one of our variables, like we did down here, so we got, using this bottom row, we were able to find that z was minus 2. Well, then we look at our second row, we have just only 2 variables in there. We have a y, because this 0 goes away. So the second row only turns into this. And so then what we could just do actually is just plug z into this equation. So we could take our z, we could plug it into here. And so doing that, we're going to get y minus 8 over 5. Z is minus 2, which is equal to 26 over 5. So what we get is y plus 16 over 5 is equal to 26 over 5. And then subtract the 16 over 5 over, we get y is equal to 10 over 5, which is equal to 2. Correct? Yeah, so then here, this gives us that y is equal to 2. All right, so now let's look at the top row. The top row of this last one tells us that we have, so 1 in front of the x, we have an x, and then 0y, and then minus 3 plus 16 over 5. So let's do this, plus negative 3 plus 16 over 5. Z is equal to, and then over here we have 9 minus 52 over 5. 9 minus 52 over 5. So now let's just, well, we know what Z is actually equal to. Z is equal to minus 2. So we can also plug minus 2 into this equation. So what we're going to get is x plus minus 3 plus 16 over 5 times minus 2 is equal to, let's see what that is. So 9 minus 52 over 5 is minus 1.4. Okay, so then we have, what is, let's see, it's minus 3 plus 16 over 5. Okay, so this is going to be x plus 0.2 times minus 2 is equal to minus 1.4. So we have x minus, so what's that times 2? Minus 0.4 is equal to minus 1.4. And then we'll add the 0.4 over, so we're going to get x is equal to 1. Minus 1, sorry. So there we get all of our three answers. We get x is equal to minus 1, y is equal to 2, and then z is equal to minus 2. Okay, let's do one more together. Hopefully one that doesn't have fractions. I think sometimes, fractions make these kind of like unnecessarily difficult. But there's a good chance they might all be like that. Let's try 32. So 32 is 2x minus 3y plus 2z is equal to 3. And then, so 2x minus 3y plus 2z is equal, oh, I already read it wrong, is equal to 2. So 2x minus 3y plus 2z is equal to 2. Then x plus 4y minus z is equal to 9. And then minus 3x plus y minus 5z is equal to 5. All right, everything looked good there. Yes, I think it seems fine. So let's, first step, turn this into a matrix. So we're going to have 2 minus 3, 2, and then 2. And the next row we'll have 1, 4, minus 1, 9. And then the last row we'll have minus 3, 1, minus 5, 5. All right, so first step, always to make this thing a 1. One thing we can actually do is there's already a 1 right here. So what we could do is to switch those two rows around. So what we can actually do is something like this. We could put row 2 here, then put row 1 here, and then just rewrite row 3. So that could be our first step. So then we'll have 1, 4, minus 1, 9. Then 2 minus 3, 2, 2 minus 3, 2, and then 2. And then rewriting row 3, minus 3, 1, minus 5, 5. Okay. So the next step, so now we have a 1 up here. Let's make everything beneath of it a 0. So what we can do, let's rewrite row 1 again. To make this a 0, we could subtract 2 of that from it. So we can do row 1 minus 2 row 1. Row 2 minus 2 row 1. And then for this one down here, to make that a 0, we can just add 3 of this. So we're going to do row 3 plus 3 row 1. So row 1's the same, 1, 4, minus 1, 9. Now row 2 minus 2 row 1, so 2 minus 2 times 1 is 0. Minus 3 minus 8 is minus 11. 2 plus 2 is going to be 4, because 2 minus 2, yeah, and then we'll have 2 minus 18, which is minus 16. Let's erase all the circles. Was that supposed to be? Yeah, minus 3. Okay, now the last row, row 3 plus 3, row 1. So minus 3 plus 3 of this is 0. 1 plus 3 of that is 13. Minus 5 plus 3 of this. So minus 8. And then 5 plus 3 of this. So what's that? 27 plus 5 is 32. So unfortunately, it looks like we're going to get another situation where we have fractions again. Sometimes there's really no way around that. So what do we do here? You know, like we said, the goal is always to avoid fractions. And what we could do now is, you know, remember, so we were solving these, sometimes it's helpful to, you know, like combine some techniques together. Or to kind of just, you know, like we had these set of rules up above. If you did follow those rules, where are we at? These guys, if you follow these exactly, you are going to get the right answer. It doesn't matter how the problem is, you'll always work. But there's sometimes it's nice to see things that are like, you know, turning, you can make things into a shortcut. In the last problem we saw a shortcut is when we immediately, so when we were at this step down here, we were able just to find, like, so when we got to this guy, we were able to find z very easily. And once we were able to find one variable, the rest of the problem sort of just kind of fell into place. So what I'm seeing now in this problem is well, we're not going to maybe be able to, because I want to always avoid fractions. One way that we can do that is well, I kind of see now that we can make this 0 quite easily because we have a 4 here. So if we did this plus 2 of that row, we would have minus 8 plus 8, which is 0. And then that would only leave us then with this bottom row only having a number here, which will allow us to find y. So what we mean by that is, so say if we did this now, let's just take row 1 the same, let's take row 2 the same, but now let's take row 3, and then let's add 2 of row 2 to it. So if we did that, we're going to have 1, 4, minus 1, 9, then 0, minus 11, 4, minus 16. Now we're adding 2 row 2 to row 3, so this plus 2 of that is 0. This plus 2 of that, so 13 minus 22 is minus 9. Now minus 8 plus 2 of that, that's 0. And this plus 2 of that, I believe that's 0 as well too. I wouldn't be doing 32. Yeah, okay. So now what we see here is, let's erase all these circles. This bottom row, let's actually put the arrow down there. Our bottom row, so like we can say our row 3 implies minus 9y is equal to 0, or just divided by the minus 9, y is equal to 0. Okay, so now we know that y is 0. But look at, so now our old row 2, what does this tell us? Well, this tells us minus 11y plus 4z is equal to minus 16. Just by looking at this row right here, we have minus 11y plus 4z is equal to minus 16. But now we know that y is equal to 0. So what this actually tells us is well, minus 11 times 0 is 0. So we have 4z is equal to minus 16. So z is equal to minus 4. Okay, so now we know what y and z is. But row 1 now, this row up here, what does that tell us? Well, that tells us that x plus 4y minus z is equal to 9. So now what we can do is we can plug z into here and y into here. So we're going to get x plus 4 times 0 minus a negative 4 is equal to 9. So we have x plus 4 is equal to 9. X is equal to 5. So we have x is 5, y is 0, and z is minus 4. So this is like a good example of a problem where it's like actually kind of nice. You get to kind of like look and see what's going on. And if you do that, it gives you a chance to like make a bunch of shortcuts. And like I always said, the goal is always to avoid fractions. But that being said, if you did just follow these steps 100% exactly up here, you would get the same exact answer. As long as you didn't make a mistake like with adding fractions and all that stuff together. Okay, that actually takes care of all the problems from this section. Let's move on to, so the last section actually of this course, so 7.4. What which is roughly the same thing as what we just did right now. Okay, let's do a couple section or problems from this section. This is 7.4. So the first one we're going to solve is number 7. Actually, let's do number 8. Number 8 says x squared plus y squared is equal to 100, and x minus y is equal to, or y minus x is equal to 2. So in these problems, we're only going to have 2 variables. But now the situation is we have an x squared and a y squared, which we didn't have before. And to solve these problems, we have to use substitution. And so we look at these 2 equations we have right here. We can call this one equation 1, call this one equation 2. We want to solve for a variable. The easiest one to choose is equation number 2. We get to solve for either x or y. If we look at equation number 2, y minus x is equal to 2. We can easily solve for y here. We just get y is equal to x plus 2 just by adding the x over. So now what we're going to do is we're going to take our equation 1. So equation 1. And we're going to plug this y value into here. So doing that, we're going to get x squared. Now y is x plus 2, so we'll have x plus 2 squared. That's equal to 100. So what we have here is x squared plus, so x squared plus 4x plus 4 is equal to 100. So we have 2x squared plus 4x, and if we subtract the 100 over, it'd be minus 96 is equal to 0. So now what we can do, let's factor a 2 out of everything. So x squared plus 2x minus, what is 96 divided by 2? 48. So that's equal to 0. And now let's factor our x squared plus 2x minus 48 terms. So we have 2x, x. So what are the numbers that multiply to minus 48, but then add 2? So plus 8, and then minus 6, because 6 times 8, or 6 times minus 8 is minus 48, and then 8 plus minus 6 is positive 2. So that factors into this. That equals 0. And so then what we get is just, so say we could divide the 2 over here, divide the 2 over here, so the 2 kind of just goes away. And what we have is x plus 8, x minus 6 is 0. So what we get here is x is going to be minus 8, and x is going to be 6. So we have those 2 answers for x values. So to find our y values, well, we look at the above. We need to plug these x values both into here and into here to see, because so basically if we have x is minus 8, x is 6, let's look at how's the best way to say this? Let's plug both of these equations, these numbers back into equation number 1. So again, let's write, here's equation number 1. We had, so we have these 2 x values for now. What was equation number 1? We had x squared plus y squared is equal to 100. And what's equation number 2? It was y minus x is equal to 2. Or what was it? Yeah, equal to 2. Let's see what happens. Let's work on now x equals minus 8. So let's plug this. This was equation 1, and here's equation 2. Let's plug this into equation 1. So we're going to have minus 8 squared plus y squared is equal to 100. So we're going to get 64 plus y squared is equal to 100. So y squared is equal to 36. And if we square root both sides, we're going to get y is equal to plus minus 6. So when x is minus 8, this is telling us that y can be positive 6 or negative 6. However, but these points, so basically this is telling us we get 2 answers. When x is minus 8, we can either get y to be 6 or minus 6. So what this is telling us is we have these 2 answers. We have minus 8, 6. So these are all points, and then minus 8, minus 6. However, if this was a solution, it also has to work for this other equation over here. So notice that if let's try this one out over here. If we did that, so we're y minus x, y is 6, x is minus 8, so minus 8. So that does equal 2, so that's good. But let's try the second one. So we're going to get y is minus 6. Then we have minus x, so that, which is, oh, sorry, no, the first one's wrong. This is going to be equal to 14, which does not equal to 2. So that tells us that this point, the point minus 8, 6 is not going to work. However, but the second one, if we plug that one in over there, we get minus 6 minus a minus 8, which does equal 2, so that works. So this tells us that we have to get rid of this one because it does not work. But this point over here does work. So this is going to be one of our answers. So again, this was the work that we did right here. Okay, so now let's do the same thing over here. We just did it for x equals minus 8. Now let's do it for x equals 6. So if we plug in 6, we're going to get 6, where are we at? 6 squared plus y squared is equal to 100. So this is going to be y squared is equal to 64. So this is going to be y is equal to plus minus 8. So 2 points. We have 6 comma 8 and 6 comma minus 8. So now we have to check both of these with the same thing over here. So we have these 2 points. The first one, all right, let's check it. So what happens if we do y minus x? Do we get the number 2? So y is 8. We get 8 minus 6. That equals 2. So this is okay. So this is going to be an okay answer, the point 6 comma 8. However, with the other one, let's try that one. So y minus x, so minus 8 minus 6, that equals minus 14, which does not equal 2, so we have to get rid of that answer. So our only answer for this problem is the 2 things in the green boxes. We have minus 8, 6, and then also 6, 8. Next one. I don't know if we could do 10. So we have 9x squared plus 4y squared equals 36. 3x plus 2y is equal to 6. Okay, so similar to the last problem. So we need to do like a substitution thing. So what we can do in this problem is, let's see. Is there any shortcuts here? It doesn't seem like it. So I think what we want to do is just, we want to choose, so here's equation 1. Oh, sorry. Here's equation 1, here's equation 2. Just like before, we want to pick a variable and solve for it and then plug it into the other equation. So let's take equation number 2. How about we just like solve, how about we do it like this way? So let's subtract the 2y over. So this tells us that 3x is equal to 6 minus 2y. And now let's square both sides of this. The reason why we're doing this is if we square the left-hand side, we get 9x squared. And 9x squared is right here, so we're just going to be able to substitute it into that. Now, if we square this right-hand side, we are going to get 4y squared minus 24y plus 36. Is that correct? Let's see. So we have that squared, that times 2. And then that squared. Yep. Okay, so now we know that 9x squared is 4y squared minus 24y plus 36. So what is, let's write down, here's equation 1. We have equation 1 is 9x squared plus 4y squared is equal to 36. But now what we can do is, we can just plug this in right there for 9x squared. So what we really have is 4y squared minus 24y plus 36. Okay, so then plus 4y squared is equal to 36. So that was this 4y squared right here. This 36, that's from this one. Okay, so what do we have? So we have 4y squared plus 4y squared, so that's 8y squared. Then we have minus 24y, and plus 36 is equal to 36. So the 36 is canceled, and what we have is let's factor out let's just write all the steps. We have 8y squared minus 24y is equal to 0. Then we can divide everything by 8. So let's divide this by 8, divide this by 8, divide this by 8. So we get y squared minus 3y is equal to 0. So we can factor out a y. And that gives us two y values. Y is equal to 0, and y is equal to 3. So now what we need to do is we have to do that same thing as the last step, or last problem. So what are our equations? We had the two equations. We had 9x squared. Let's write them down again. 9x squared plus 4y squared is equal to 36. And then also 3x plus 2y is equal to 6. So now let's plug in y to be 0 in this left-hand equation. Let's try this one out. So what happens when y is 0? So we're plugging it into this left equation. So if we do that, we're going to get 9x squared plus 0 is equal to 36. So we have x squared is equal to 4. X is equal to plus minus 2. So what we get is 2. We get 2 comma 0 and minus 2 comma 0. But what happens, just like before, we have to plug these into the other equation to see if they work. So if we plug this one in, so we get x is 2. So this is going to be 6 plus, and y is 0. So 6 plus 0 is equal to 6. So that one works. So this is a solution. See what happens when we plug in the other one. What we get is, so x is minus 2, so we're going to get minus 6. Y is 0, so plus 0. That's equal to minus 6. That does not equal 6. So this one we have to get rid of. And you see we need this to equal 6. And so that one just equaled minus 6. So that's not going to work. Okay, so now what was the other y value? We got over here a y value of 3. So let's see what happens when we plug y is equal to 3 in. So when y is 3, so again, we're plugging it into this equation now, we will get 9x squared plus 4 times, so 3 squared, which is 9, is equal to 36. So that 4 times 9 is 36, subtract it over, we get 0. So we get 9x squared is equal to 0. And this one, we just get x is equal to 0. So we get the point 0 comma 0. One second, something doesn't seem right here. Did we make a mistake? What number are we doing here? This is number 10. I think we have the answers to this one. 2 comma 0, 0 comma 3. We get 0 comma 3. Oh, sorry. Yeah, no, we're okay here. So we plug in y equals 3 and we get x is equal to 0. So the point we get is 0 comma 3. So now let's plug this point in. So this, we only get one of the points for this part, the y equals 3 part. So let's plug this in and see what happens. So x is 0, so we get 0. 2 times y, so y is 3, so 6. That does equal 6, so we're good. And so that must mean that we have this answer as well too, 0 comma 3. All right, so those two answers for this problem. Okay, that's actually good for this section. We can stop here for the day. That takes care of all like the homework problems. So I believe tomorrow is Friday. So Friday and Monday we are, I can look this up real quick, because I think our test is on Tuesday. Where's the schedule? Yeah, so we'll review today, or we'll review tomorrow, then review the next day, and then we have the next class period. So we'll review next Monday, and then the test is on Tuesday, and then we have a couple more days of review, and then the final. Okay, cool. So thank you. I'll see you guys tomorrow for the next video. Thanks.